So, if you're a researcher, you know some of the coolest, most cutting edge experiments are happening at this intersection between small devices out in the world, the edge, and the incredible power of the cloud. The problem? Actually connecting them is a massive headache. Today, we're going to look at a tool called Kiso that's here to change the game. Have you ever found yourself in this situation? You're trying to set up an experiment that stretches all the way from, say, a tiny sensor in a field to a massive cloud server that can process all that data. It sounds awesome, right? But if you've been there, you know exactly what the reality feels like. The reality is, it's just a huge pain. It's this incredibly complex, fragile process. You almost feel like you need a PhD in systems administration just to get the basic foundation working. And all that time you're spending fighting with the infrastructure, that's time you are not spending on your actual research. All right, so here's our game plan. First, we're really gonna unpack that edge-to-cloud headache. Then we'll meet Kiso, the tool designed to fix it. We'll look at its secret sauce, this master plan for experiments, then see its automation superpowers in action. And finally, we'll talk about the new frontiers this whole approach opens up. Okay, so let's get into it. The edge-to-cloud headache. Why on earth is this so difficult? Let's break down the manual struggle that so many researchers have to deal with. I mean, just look at this. This is the mountain of work you have to climb before the science can even begin. You're setting up machines, you're wrestling with network configurations, installing every piece of software, and then you're just crossing your fingers, hoping you can do it all again perfectly for the next run. For a lot of folks, this setup can take even more time than the experiment itself. But what if there was a better way? What if you could just automate all of that? Well, that is exactly where Kiso comes in. Think of it like your personal automated lab assistant built specifically for these complex setups. So what is Kiso exactly? At its heart, it's an open source framework that basically automates the entire lifecycle of your experiment. It handles the setup, the deployment, the execution, everything you need to create this seamless bridge from your devices on the edge all the way to the cloud. And really, this is the whole point. It's designed to take care of all that tedious, frustrating, error-prone infrastructure work, so you can get back to what actually matters, your research. Okay, so how does Kiso pull this off? It sounds like magic, right? Well, it all boils down to one incredibly smart idea: giving your experiment a single, powerful master plan. Instead of writing a ton of messy, complicated scripts, you just describe your entire experiment in one single human-readable YAML file. It's like a master recipe that tells Kiso exactly what to build from the bare metal all the way up to the final commands. And this master plan has 4 key parts. First up, you have sites. This is basically the where. You tell Kiso what resources you need. This could be a big, powerful machine on a research cloud like Chameleon, or hey, maybe it's just your own laptop using a tool like Vagrant for some quick local testing. Next, there is deployment. This is the what, the logical blueprint of your setup. For example, you could say you want to set up what's called an HT Condor pool. You'd have one machine as the boss, the central manager, and then other machines as the workers, the execute nodes, doing all the heavy lifting. Number 3 is software. Pretty straightforward, right? This is the how. You just list all the tools and programs that need to be installed, like Docker for running containers or Pegasus for managing your scientific workflows. And finally, you get to the part you actually care about, the experiments. This is the why. This is where you specify the actual science, the scripts, the commands, the workflows that Kiso is going to run once everything is perfectly in place. So how does Kiso know which software to put on which machine? This is where it gets really clever. It's all about using simple labels. For example, in your sites file, you might tag a Raspberry Pi with the label Edge Node. Then, in your software file, you just say, "Hey Kiso, install Docker on anything with the Edge Node label." That's it. It's such an elegant way to map what you need to where it needs to go. So you've written your master plan. Now you hand it off to Kiso. And this is where the automation really takes over, going from that one single file all the way to the finish line. The moment you give Kiso that YAML file, it just runs the whole show. It goes out and provisions the resources you asked for, it configures the entire infrastructure, it runs your experiment, it gathers up all the results and artifacts for you. And maybe the best part, when it's all done, it cleanly tears everything down so you don't leave things running by mistake. Just think about what this makes possible. You could literally define a setup where the brain of your operation, the central manager, is on a powerful cloud server. The node where you submit jobs could be your own laptop, and the actual work could be getting done by an execute node on a tiny Raspberry Pi sitting on a lab bench. Kiso orchestrates that whole distributed dance for you automatically.
Now, this is obviously amazing for running workflows, but the potential here is actually much, much bigger. We're talking about unlocking whole new frontiers for research. Because Kiso is so flexible, it's not just for simple linear jobs. It can handle these really complex, agent-based systems. A great example is a framework called Colmena, which lets researchers create simulations where lots of different software agents can think and react on their own. People are using this right now to model things like modern power grids.
And this isn't just some theoretical tool. It's built for the real world of scientific computing. It has built-in support for major research testbeds like Chameleon and Fabric, plus Vagrant, which is fantastic for just prototyping an idea on your own laptop. But at the end of the day, all this automation and power serves one of the most fundamental principles in all of science. It's captured perfectly in this quote: "The idea that by defining your entire experiment in one file, you make your research transparent, repeatable, and most importantly, independently reproducible." And that really is the perfect place to leave it. It brings us to the big question. With that headache of manual setup finally gone, what complex, amazing edge-to-cloud experiment will you build? Kiso gives you the foundation. The rest is up to you.